So hello guys, welcome to another video, and in this video we're going to be discussing about the question that is sequential digits on LeetCode. Now although it's given as a medium level question, but I would very much say that it's kind of an easy level question. And let's see when we explore this question. So there's an integer has sequential digits if and only if each digit in the number is one more than the previous digit. So for example, as you can see here that 1, 2, 3, 4 is a sequential digit number because like all the digits are like one more than the previous digit. So 2 is one more than 1, 3 is one more than 2, 4 is one more than 3. So that's how all the numbers are. So we have to return the sorted list of all such integers in the range of low to high that has been given to us. Now let's see how we are going to approach this question. So first of all, as you can see that suppose we write the sequence of 1 2 2 3 3 4 4 5 5 6 6 7 7 8 8 9, right? So these are all the 2-digit sequential numbers that you can have. So I will give you basically two intuitions, okay, that you can follow in order to solve this question. One intuition is you can basically think you start from the second number of the previous sequence, and you start by adding a digit just right before it, okay. Now here you have added 1, here you have added 2, suppose, okay, here you have added 3, here you have added 4, here you have added 5. All these digits you are adding right before that previous number, and you're starting from the second number of the previous sequence, okay. Here you're adding 7. The same thing when we have to switch from 3-digit to 4-digit numbers, sequential numbers, we'll do the same thing. We'll start from the second digit of the previous sequence, and we'll start by adding 1 first, then we'll add 2, then we'll add 3, then we'll add 4, then we'll add 5, then we'll add 6. So these are all the sequential 4-digit sequential numbers that we can get, and like this we can continue the sequence until and unless we get this number that is 1 2 3 4 5 6 7 8 9, because obviously it can't go any higher than that, because this has all the 7 consecutive digits, okay, that are there. So fine. So this is one kind of intuition that you have. Now, the next kind of intuition that you have is that you don't need to start from the second element of the previous sequence, okay. You can start away right from the first sequence, element. Simply what you need to do is you need to extract the last digit, that is 2 here, okay. You need to multiply this number with 10 first, and this last digit that you have extracted, you have to add that with 1, and you have to add this. So this is basically 120 plus 3, that is equal to 123. Here you again extract the last digit, you multiply this whole number, that is 23, by 10, and you add it with 3 plus 1, that is the last digit, plus 1. So here also it is like 230 plus 4, that is 234. So as you can see, it is 123, 234. So similarly, it's just going to be 345, 456, 567, 678, 789, right? It's going to be till here. The same way, just the next level, again we're going to get 1 2 3 4. 2 3 4 5, because we're simply extracting the last digit and like adding it with 1, okay, and adding it at the very last again. So we're getting the number of the next sequence basically. So as you can see that level by level we are basically having like kind of sequence of numbers that are changing. So this intuition we can also refer it to as BFS, breadth first search, which is kind of a level order traversal, which we can link here. Now it's not exactly the same, I won't say it's exactly the same, but it's kind of similar to that, okay. So we can implement it quite like that. So BFS is like implemented anywhere where we have multiple steps at once with same weights or same weightage. So as you can see that we are applying the same operation on all the numbers that are appearing in the previous sequence in order to get the current level, right? So whatever numbers that were present in the previous sequence, we are applying the same operation that has been mentioned over here, that is first by extracting the last digit and adding it with 1, and then adding it with the previous number multiplied by 10. So we are applying the same operation on each and every number that is present in the previous sequence in order to get all the numbers that will be present in the current sequence. So this is exactly what BFS is meant to do. So like it's basically creating 1 levels, and each level is basically helping to derive the elements of the next level. So this is exactly what level order traversal is. So now let's jump right into the code. So for implementing BFS, if you've not watched any video that has implemented level order traversal of BFS, I would urge you to go and watch some simple tutorials based on that. It's not really that hard. It's very simple. You can just visualize it using the BFS level order traversal of a tree or a graph. So now first of all, what we'll do is we'll take a queue. Okay, now that's how we just do the BFS. We just store all the numbers of the current level in the queue, and then we pop one element of the current level, and we just keep on adding the processing them and pushing them up again in the queue in order to assess the next level of the sequence. So initially what we do is that since here we had started with 12, 23, this actually we can also start with 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 3, 4, 5, 6, 7, 8, 9. Now why is that? Because we extract the last digit of 1, that is 1 itself. We added with 1, that is 1 plus 1, 2, and we added with 1 into 10, right? So that becomes 12, right? That becomes 12. Now for 2 it becomes 23, for 3 it becomes 34, for 4 it becomes 45, for 5 it becomes 56. So that way it just goes on. So that is this exact step that is happening, that is also happening on the single digit numbers. So that's what we are going to be doing here also. We are going to be initially copying all the single digit numbers from 1 to 9 into the queue. We're just going to be pushing them into the queue. Now we're going to be iterating until the queue is empty. Okay, we're just going to be doing that. We're going to be extracting one number from the level, say, and then we're going to pop it to the current level because we have no more use of it. We're going to see if this number is greater than the high range that we have, because if it is, then all the numbers that are going to be processed and stored in the next stages will always be greater than this current number, right? Because we are just multiplying it with 10 and then adding it, so it's always going to be higher. So if this current number is already higher than the high range that we have, then all the numbers that are coming up will also be higher. So we are simply going to break it from this loop. So now if the number extracted from this current level is basically it falls in the range that is greater than or equal to low, then we simply push it back into our answer vector or answer array that we have. Okay, so here we are going to be using a vector, and we're going to be pushing the number extracted if it falls in the range. So I'm just going to be taking this vector over here. Okay, so now what we're going to do is, now checking is done. Now we're going to process this number. Now what 2 steps did I tell you? We're going to be extracting this last digit of the number of that previous level that we extracted. We're going to add it with 1, and then this thing we're going to add it with the number multiplied by 10. So let's extract the last digit. Okay, we are going to be doing that by simply doing modulo 10. Now if last digit is less than 9, only then we'll add the processed version into the queue for the next level. Because if the last digit is equal to 9, then this 9 plus 1 is going to be equal to 10, right? So that doesn't stay any single digit anymore. So we can't do 10, like we can't multiply it with 10 and again add 10. We can only add this thing right here that we were adding, the 2 plus 1 that we were adding. We can only add a single digit number because it gets added at the last, because when 10 is multiplied with the previous number, the 0 comes at the very last, right, for only one digit. So we can't add a 2-digit number that is 10 over there. So we need to limit our last digit to 8 itself, so that 8 plus 1 is 9, and then 9 can be added. So what we add into the queue for the next level is t into 10 plus the last digit plus 1, right? That's exactly what we do. So, and when the number goes higher than, so like for every sequence like this, the numbers are, the processed numbers are getting added, the modified numbers are getting added into the queue, and they're like being extracted, popped, and then they're being checked again, processed, and then again the next level elements are going to be added into the queue. So this process is going to continue until and unless the number that is extracted falls in the range of low and high. If it does not, if it goes higher, then we simply break it, because we know that all the numbers that come up are always going to be higher. So we simply return the vector that we have formulated. So let's see if this gives the right answer. So perfect, this gave the right answer right here. Let's check for the example test cases. Okay, this gave the right answer again. So let's submit it and check. It's perfect, right? So here we have learned about how to there was the intuition was just basic mathematics. If you see, we have just learned the concept of level order traversal, or BFS, you can say. This is basically a process in which we have multiple steps with the same weightage, like multiple steps with the you can say the same architecture of steps. And at every step you are basically formulating the elements that you're going to have in the next level. So for every level you are having a set of elements, and you're going to use those elements, do some operations on them, and you're going to formulate the elements that are going to be present in the next level. So that's what I do in BFS, and this question was as I said, relatively simpler than medium level question. So I hope you like the video. If you have any doubts, you can post them down in the comment section, and if you have any suggestions for next upcoming videos, you can post them in the comment section again. So that's all for this video. I hope you liked it. Thank you, and have a nice time.